Hello, my name is Joshua Nelkin, and this is my relief drone, which I called the Landcrawler. During this project, we set out to create a remote-controlled drone that would be capable of delivering a care package for disaster relief. The design must be capable of transmitting motion, securing the relief package, and steering. All three of the motions must be completed using three motors and must use a mechanical mechanism in order to move the different features. It also has to have a power storage device, recharging mechanism for the power storage device, and a chip to control the several motors so that it is completely remote. And during the Imagine phase, I began by thinking about the types of remote control vehicles, and I included the specific features of each type of design that I thought about and included them into the mind map, and I used the mind map to combine them into the features I found the most compatible with each other. So you'll see that in a second. Here's the mind map. As you can see, I had a couple different steering mechanisms, had a couple different propulsions, different package carrying mechanism. I basically just made a couple broad types and used these parts to come up with like different ideas. And I thought that was pretty unique. I haven't really used mind mapping before, and I learned how to do that with this, and I think that was pretty useful. Here's my first design. This is the land crawler design that I came up with originally. As you can see, it's completely different looking from what the final design I came up with was. It had ball joints here that would turn back and forth, and it had a rack and pinion moving. It had a couple gears. I For this, if I would have designed designed something like this again, I would probably get the proper paper because drawing on line paper made the perspective look really weird on all of them. And here's another one. Here is my like actual drone. It is the flying drone, and it has a this is a computer chip on top, and it would have a like kind of like claw thing below, and obviously the four propellers. And I would use two of the motors to propel two of the blades each. So yeah, and then this was my final design, which is the boat design. Little propeller on the back, the boat engine, and the gears to turn it. And then in the middle for the release mechanism was a little crane that I was going to make, and also a windmill. For the select, I ended up selecting the buggy drone because cost of it was the most cost effective, and it was like the most recyclable. It had the best adherence to the theme, and I didn't think it was the most creative design, but I felt like it was the most doable, and I felt like I could apply the most creative ideas to this design. And I really wanted to have very complex mechanisms, and I think with this design, it allowed me to do the best on that. And I, I've kind of learned this from previous 3D modeling experience where you cannot go too overboard or you will not be able to complete the product on time. And that's what this kind of taught me as well, is that I really need to not go too far above the constraints because then I cannot finish in time. And during the create portion, this was the portion where I spent the majority of my time. Uh, I ended up having a total of 60 components, so even though I planned to not go overboard, I kind of did a little bit. Anyway, um, within my design, there were also repeated components, as you can see. I attempted to take my design sketch and transform it into a more feasible shape and completely reimagined the mechanism for steering. I did research into car steering. I also rethought the package release mechanism because my original design required the parts to interact in a way that would be very difficult because of the ball joint and the movement of that. I don't think there would be any way to do that on SolidWorks that would be very easy. And here are the little part groupings. Since I had so many parts, I just decided to kind of group these up in little sections. So this was my first little grouping. This is the rear drive. It is a back rear drive vehicle, and as you can see, this little motor here would spin this gear, and that would spin these tires. This is the front steering mechanism. As you can see, that those are turn bars. So when this moves back, this moves the wheels from left to right. Actually, this is part of the reason or part of the mechanism behind like some cars steering wheels, and it's pretty interesting. Here was my release mechanism. As you can see, this motor would spin, and then that would spin this whole bar, which would end up pulling this rack back and forth. and these are just the all not stationary components, like the battery right there. This is the computer chip, and this is the solar panel. Uh, yeah, that was all the important power supply parts. For movement, I'm just gonna let this video play. So as you can see, this would move back and forth, which would move this back and forth. I didn't really give a good angle there, but you can see right here, this moving like that would allow that to move right, and move the other way would allow it to move left. This gear would spin, which would spin the tire. And then finally, when this bar rotate, this will move out. It is a little glitchy on that last one because of the amount of mates on it, but it still worked pretty well. If I were to do that again, I'd probably try to simplify that. Sorry about that. Anyway, part drawings 1 through 3. Here's the slide which connected to the slot that was a part of the steering mechanism. This was a part of this was what the motor spun on the back drive train. And then this is the motor that I used for every single one. It's not a real motor, obviously, but it does the job of the motor and shows how it would work. This is the turn shaft that I talked about earlier, and this is the little wheel connector that connects to this turn shaft and then moves back and forth. Exploded / alternate view right here. As you can see, there's quite a few parts on here, so I'm not going to go into every one, but I'll kind of broadly talk about them. For the majority of the components, I used ABS and some sort of steel, either cast alloy steel or stainless steel, depending on whether I CNC'd it or I casted it. And all of the plastics that I used, I decided to use 3D printing because I think it's the most time effective for complex components. And the overall cost of materials from the actual price of each part came out to be like $3,244.44. And a majority of the parts are made of some form of steel or ABS, as I said. And yeah, if I were to do this again, I would definitely look more into the mass of the parts I'm creating, because especially for this drone body, it was extremely heavy, which made it basically the most expensive part. So I would definitely hollow that out and make it more efficient if I did this again. I definitely learned a lot about the design process. You really need to pay attention to how much your parts weigh, because it will end up making a big difference. And for this project overall, it led me to gain a vast amount of knowledge about SolidWorks part design, and it allowed me to increase my part creation by a huge amount. If I were to redo this project again, I'd put more thought and research into the material and mass of each part. And yeah, I would look for basically any way to cut them down in cost and maybe find the most effective material to do the job, but maybe for less money. And I have sincerely enjoyed this project, and I've gained a lot from it, and I would love to do something like this again. It was very fun. And thank you very much for your time, and thank you for watching. Have a good day.